Alright, this is section 6.4. This is day 2 on factoring polynomials. We started factoring polynomials, I believe last week, but we didn't finish it. We only got to do a sum of two perfect cubes and difference of two perfect cubes. But we need to learn a couple more different methods, so that's what we're doing at day 2 on it. Okay, but to start, well, first we always start the same way. We're going to highlight our essential question. What are some ways to factor a polynomial, and how is factoring useful? Is the goal of today. To start, what I want to do is a little bit of review of what we have already learned, right? We have already learned how to factor difference of two perfect cubes, so that's what I want to start with today, just to refresh your memory. And I do know that a lot of you guys are still struggling with these factoring techniques. Okay, so let's review that by doing a couple of examples. Let's go ahead and get started with number 1. It says factor completely 40x to the fourth plus 5x. So in your notes from when we were doing these, I told you guys to write something on the left side that should say always factor the GCF out first, right? We always look for the GCF first. First of all, if I try to factor this, I don't see any of our special patterns. This is not a perfect cube. This is not a perfect cube. This is not a perfect cube, okay? And it's not a trinomial that I can do x factor on. So the only thing left is to try to factor out the GCF, which is what I'm going to try to do. Okay, so GCF, meaning what do they have in common? 40 and 5 can both be divided by 5, so we're going to divide by 5, right? That's what factoring out the GCF means. That means dividing by something, by the same thing. And also, if you notice, both of them have x, so we're not going to divide by 5, we're going to divide by 5x. Okay, so 5x goes outside, and then what's left after division? 40 divided by 5 is 8. X to the fourth divided by x. The rule for division of powers is to subtract the exponents, right? So 4 minus 1 is 3. X to the third. Plus 5 divided by 5 is 1. X divided by x is 1. So that whole thing is just 1. It does not go away and become 0. Okay, it's 5 over 5, which is 1. Or x over x, which is still 1. Alright, at that point, you have factor out the GCF. Always check what's left. Check inside the parentheses and ask, can I continue factoring? Is there something I can do at this point? The answer here is yes. That's a perfect cube. That's a perfect cube. That's a perfect cube. It's 1, which is 1 times 1 times 1. So we're going to use our sum, this is a sum, of two cubes pattern to factor this out. Okay? Perfect cube, which is 8. I'm going to write it as a perfect cube. So for now, this is what I'm going to do. I am going to leave this off, but we have to remember to make sure we write it there at the end, okay? So I'm just worried about this part right now. I'm only working on this part, but that 5x has to be there at the end. So I'm going to rewrite that 8x cubed as 2 cubed, why yellow? 2 cubed, x cubed plus 1 cubed, right? I wrote all of them as cubes. 8 is 2 cubed, x cubed is just x cubed, and 1 is 1 cubed. And now what you do is set up your parentheses. Your first one will be a binomial, your second one will be a trinomial. What goes in the first one? All of these things without the cubes, right? You're basically getting rid of the cubes. So it's just 2x plus 1. 2x, there's the 2, there's the x, there's the 1. 2x plus 1. In the other one, remember what I said, don't even look at these anymore. Just look at what you just wrote. All of your answers come from here. The first term is the first one you just wrote squared. So 2x squared makes 4x squared, right? Because you got to square the 2. 4x squared. For the middle term, you multiply them times each other, but change the sign. So if you have a plus here, make sure that this one is negative. If you have a minus here, make sure that this one is plus. 2x times 1 is just 2x, so it's just going to be minus 2x. Once again, minus because it has to be the opposite from that one. And finally, your last term is this second term squared. So the 2x plus 1 came from here. Basically, I got rid of the cubes. I wrote everything as cubes, then got rid of them to write it like this. Then I take the first term and square it, times each other, that's the middle. square the last term, and that's 1. And the last one is always going to be positive. So the middle one is going to be the opposite of this one, but the last one is always going to be positive. All right, now all I got to do is remember to write the 5x that I factored out at the beginning, this one, right here in front. And I'm done. You should always check to see what you have left to see if you can keep going. But at this point, there's nothing to factor here. This is a quadratic, and I know that this quadratic is always going to be irreducible. If you do a perfect sum of two perfect cubes, or the difference of two perfect cubes, your quadratic here is never going to be able to be factored out. Okay, it's going to be irreducible. So at this point, you are done. You have factored completely. Okay, watch me do it again. 16x to the fourth minus 54x. First, factor out the GCF. Think 16 and 54. What do they have in common? And let's try 16. No, 16 doesn't go into 54. 8 doesn't go into 54. 4. No, 4 doesn't go into 54. The only thing I can think of is 2. Let's factor out 2. Divided by 2, divided by 2. Not just 2 though, look at the x's. They both have x. How many can I factor out? Just one of them, right? If they both have it, factor out the smallest amount, the one that has the smallest exponent. So 2x is what my GCF is. We're going to factor out 2x, leaving me with, let's divide. 16 divided by 2 is 8. X to the fourth divided by x, that means subtract the exponent, so that's x cubed. Minus 54 divided by 2 is 27. And x divided by x cancels, so that's what I have left. Once again, I am going to highlight this and make sure I remember to bring it back at the end, but right now I do not need it. I'm just going to focus on this part right here. I'm going to write all of this. I do notice that the 8 is a perfect cube, this is a perfect cube, and the 27 is a perfect cube. So I'm going to rewrite them all as perfect cubes. What is 8 as a perfect cube? You should say 2 cubed. Leave the x cubed. So notice I'm writing all of them with cube because then I'm going to get rid of them. Minus 27 is 3 cubed. So 8 is 2 cubed. This is x cubed already. I don't have to rewrite it. And this is 3 cubed. Now I'm ready to write my parentheses. The first one is a binomial. The second one is a trinomial. For the first one, all you got to do is look at this, what you just wrote, and get rid of the cubes. It's 2x minus 3. And then for the second parentheses, don't even look at this anymore. Just look at what you just wrote. Your answers come from here. Square the first term, times each other, square the second term. So square the first term. 2x squared, that is 4x squared. Times each other. 2x times 3, that's 6x. Since this is negative, it's going to be plus 6x. Remember, these signs, this one and this one, are always going to be opposite of each other. So this one you keep from the original, so the other one must be positive. The final sign must always be positive, and you square the last term. 3 squared is 9. There you go. Let's not forget the 2x that I highlighted from earlier. That goes in front. And now we're done. There is nothing else I can factor out. Alright, so at this point I'm going to ask you to go to your side and try number 1 on your own. There's a typo here, just noticed it. So on your paper, it should look like this, unless I messed up somewhere in the worksheet. But either way, it should not say 64. Let's fix that. Let's just cross it out completely and write it again. It should say 2x to the fourth plus 128x. That's what I meant to write. So go ahead and try that, okay? And as always, when I ask you guys to do one, take your time, do it on your own. Pause the video right now, do it yourself, then come back and check how I did it, okay? Go ahead and pause the video now. Alright, and here's my work. 2x to the fourth plus 128x. I started by identifying the GCF, which is 2x. So I divide both by 2 and also by x because they both have an x. So the 2x comes out, and then what's left from this division is x cubed, and from this one is just 64. Then I took the x cubed plus 64. Notice that I highlighted the 2x again because I didn't want to mess with it. I just want to make sure I remember to write it there at the end. Just focus on this. This is a perfect cube, and this is a perfect cube. 64 is 4 cubed, so I wrote them both as perfect cubes. X cubed plus 4 cubed. Get rid of the cubes, and it's just x plus 4. That's where that came from. Then for the last parentheses, what I did is I took the x here and squared it. Multiply them times each other. X times 4 is 4x, but remember the signs must be different. So if this one's plus, this one's minus. And 4 times 4 is 16. And then we are finished by just bringing the 2x, and that is your final answer. Alright, so let's go back to my side. We're going to factor some more polynomials by grouping. Grouping is something that you have already done before. I've shown you already how to factor by grouping before. We're just going to practice a little bit more now, okay? And we've only done it before with quadratics. We're going to be working on cubics and also a higher degree like quartics and so on, okay? But the idea is the same, something that you have already learned before. So let's start with number 3. So it says x cubed minus x squared plus x minus 1. Factoring by grouping, factor by grouping means exactly what it sounds like. You're going to group your terms together in a specific way. You're going to group them in pairs. So I'm going to take these two and put them together, and I'm going to take these two and put them together. And what you're going to do for each of those pairs that I just made is factor out the GCF. If they don't have anything in common, factor out 1 every time. If they have nothing in common, factor out 1. Okay, so you still must factor something out. You can always factor out 1. Everything is divisible by 1. Okay, so let's start. For this one, x cubed minus x squared, what do they have in common? And you should say x squared. X squared. I was going to say just x, and then I realized that it's actually squared here. We're going to factor out x squared. They both have x. The one with the lowest degree is the one you factor out. So you were going to factor out x squared. So I have x squared on the outside. And then what's left on the inside? X cubed divided by x squared is just x, right? Subtract the exponents. X squared divided by x squared does not go away, it doesn't erase, okay? It's going to be negative minus, because of the minus there, 1, right? The division between those two is just 1. All right, for the other one, x minus 1, I notice that they have nothing in common. If they have nothing in common, I said factor out 1. So I'm actually going to divide them both by 1. That's basically all you're going to do, divide them by 1. So you're going to have a plus 1 on the outside. And then what's left inside? Well, when you divide by 1, nothing changes, so it's just x minus 1. And this is where the factoring happens again. What we're going to do now is look at what we have. I notice that both of them have x minus 1. What we do at this point is basically taking out the GCF again. You're basically thinking, this is what we're doing. You're saying this is one term, and this is another term. What do both of those terms have in common? X minus 1. So we factor out x minus 1, which is the GCF of both of these terms. That's basically what we're doing when we factor by grouping in this form. So x minus 1 is what they have in common. X minus 1. That comes from this one and this one. They both have x minus 1, so that is my first parenthesis. My other parenthesis is what's left. When I factor out x minus 1, what's left? X squared plus 1. Okay, at this point, you're not done. You have to try to keep going. If you have a factor that is linear, meaning the degree is 1, you're done with that one. There's nothing else to do. But if your degree is bigger than 1, you got to try to keep going. Try to see if there's anything else you can do. Look for a difference of 2 squares, or a sum of 2 cubes, or a difference of 2 cubes, any of the patterns that we have noticed. Or maybe it's a trinomial and you can do x factor, but you got to try to keep going. So this one's done, but this one is it's a square and a perfect square. So you might think I can use difference of 2 squares, but no, we cannot because of the plus sign, right? If it was x squared minus 1, that would be perfect squared minus a perfect square. I could factor that out into x plus 1, x minus 1. Remember that pattern? But it's not, right? It's x squared plus 1. That plus messes it up. There is no sum of two squares pattern. There's a difference of two squares patterns, but there's no sum of two squares pattern. There's a sum of two cubes pattern, but no difference, sum of two squares pattern. So no, we can't keep going. You're done at that point. That is your final answer. All right, let's try another one. Number 4. X to the fourth plus x cubed plus x plus 1. So they already set it up in standard form for me. All I got to do is just pair them up. I'm going to pair these two and then pair these two and see what they have in common. So the first pair, x to the fourth and x cubed, what do they have in common? They both have x, so we're going to divide by x. They both have x. The question is how many? Whichever one has the smallest degree, that's the one you're going to take out, x cubed. So when we factor out x cubed, what's left? X to the fourth, take away x cubed, or take out x cubed, and you're left with x. X cubed, take out x cubed, and you're left with, not 0, you're left with 1, plus 1. For the other one, they have nothing in common, so factor out a 1. Always, you're going to divide by 1. If they have nothing else in common, you factor out 1. So factor out 1, and you're left with x plus 1. Also, another point that I need to make, if the first term was negative, I would factor out negative 1, because we always want the first one to be positive. So if it was negative x plus 1 here, I would say I'm going to divide by negative 1 to make it positive. It didn't happen in that case, but just in case you guys encounter it, factor out negative if it happens to be negative there. Okay, now at this point I notice that they both have x plus 1, so that is my first parentheses. X plus 1 comes from both of those. And then your second parentheses is what's left, x cubed plus 1. Do not circle and say you're done. Check, okay? This one is linear, right? The power is 1, the degree is 1. Done. This one is cubic. It's not done until you check. Is there anything I can do to factor this more? Think about it. Think about it. Yes, we can, right? This is a perfect cube. This is a perfect cube. Yes, it says plus, but we do have a pattern for perfect cubes. We've been using it. Just like this one. Perfect cube plus perfect cube. We can break it up using this pattern right here. Okay, so let's work on that. I am going to highlight the x plus 1 factor because it's done, right? But I just got to remember to write it there at the end. What I'm going to be worried about is this part right here. I'm going to write that as two perfect cubes. X cubed plus 1 cubed, right? Because 1 is a perfect cube. It's 1 times 1 times 1. Notice that I have two perfect cubes, and I write my parentheses. One for a binomial, one for a trinomial. Get rid of the cubes, right? That's the pattern. Get rid of the cubes and just write x plus 1. And then the second one is a trinomial, 3 terms. Square the first one, it's x squared. Multiply them times each other, it's x plus 1. X times 1, which is x. But it's going to be negative, so negative x. Again, why negative? Because it must always be the opposite of that sign. And the last one is just 1 plus 1. That's it, except I gotta make sure I bring this one down, so it's x plus 1 right there in the front. Like that. Okay, you're done at that point, but there's something else I can do. If you leave it like this, it's fine. I'll take it. But I do notice, and you should too, that there's two x plus 1s. Oops, let me undo that. There's two of these, right? X plus 1 and x plus 1. I can put them together and write it like this. X plus 1 squared. Because there's two of them. Times x squared minus x plus 1. And there you go. The one that I highlighted in yellow or the one that I circled with the red box, either one is actually correct. We do prefer this one, right? The simpler the better. Okay, this is completely factored and we combine these two into x plus 1 squared. So again, let me recap here. We grouped them together, factor out the GCF from each one, and got this. You do not stop. You got to check. Okay, that one's done because it's linear. If you see that it's linear, you're done. There's nothing else to do. But if you see that it's quadratic or cubic or quartic or anything higher, you gotta check. What else can we do? I noticed that they're both perfect cubes, so I wrote them as perfect cubes. And then I used the pattern, ignoring the x plus 1, right? This one was left over. All I worried about is this. And so I took the x plus 1, taking out the cubes, and then used the pattern where you square the first one, times each other, square the last one. And then I brought down the x plus 1 here, put them together to make x plus 1 squared. And that's it. Okay, at this point I'm going to ask you guys to go to your side and do number 2. But just like the last one, we're going to change it. I'm realizing that I'm giving you guys bad examples in your side. So we changed the first one. We're also changing this one, okay? So cross it out and change it to this instead. Let's do 5x cubed. 5x cubed minus 6x squared minus 15x plus 18. Let's do that one instead. The reason I'm getting rid of the other one is because it actually does not work, so I must have typed it in incorrectly. So let's try this one instead. 5x cubed minus 6x squared minus 15x plus 18. Okay, go ahead and do it yourself. Pause the video right now, try it on your own, then come back and see what the correct answer is. Okay, here you go. You can see my work right here. I started by grouping 5x cubed minus 6x squared together and grouping negative 15x plus 18 together. I factored out the GCF of the first two, which was x squared, and of the second two, which was negative 3, right? Why negative? Because I noticed that the first term was negative, and I do not want it to be negative. I want the first one to be positive. So I factored out negative 3 first. So x squared from the first one, leaving me with 5x minus 6. Negative 3 from the second one, leaving me also with 5x minus 6. So then I notice that I have 5x minus 6 as a common factor here. That's the GCF of these two. So 5x minus 6 is your first parentheses. The other one is the leftovers, x squared minus 3. At that point, you're done. I made sure to check first. This one's done because it's linear, right? We said if you're linear, you're done. There's nothing else to do. This one is quadratic, so I checked. But since this is a perfect square, but this is not, I couldn't factor it out. If this had been a 9 or a 4 or a 16 or a 25, all those perfect squares, I could keep going because there's a pattern of the difference of two perfect squares. But since it's 3, it throws me off. It doesn't work. We're done at that point. Alright, let's go back to my side and work on number 5 and number 6. Solving some real-world problems by factoring a polynomial is the goal. We're going to try to solve these problems by factoring, which is what we have been learning. So let's say number 5. A water park is designing a new pool in the shape of a rectangular prism. The sides and bottom of the pool are made of material 5 feet thick. The interior length must be twice the interior height, which is the depth, and the interior width must be 3 times the interior height. The volume of water that the pool holds must be 6,000 cubic feet. What are the exterior dimensions of the pool? Alright, there's a lot of information there. I think what's going to help us is if I can get an image of a pool, of a rectangular prism, that could help us figure this out. Let me see if I can get that. Here you go. I found a picture of a rectangular prism, which could represent our pool. Here's the depth, which is the height. They call it the height here, or the depth. And there's the width, and here's the length. Okay, so using that and knowing that it has to have a certain thickness, so I can see here that it does have a certain thickness. You guys see that little distance. The sides and bottom of the pool are made of material 5 feet thick. So the thickness of the material is 5 feet. When you calculate the volume of water that the pool holds, you don't care about the total distance outside. You care about the total distance inside, right? Does that make sense to you guys? If I'm caring about the volume of how much water the pool can fit, I don't care that this is 20 feet or 30 feet. I care how far away the walls are on the inside of the pool. So the interior depth, the interior width, the interior length, not the exterior. Okay? But the question is asking us for what are the exterior dimensions of the pool. First, to find the volume of a rectangular prism, I need to know the formula. We've done this formula, we've used it a couple of times before. Length times width times height is the formula for the volume of a rectangular prism. Okay, looks like in the problem we've already started some of the expressions, okay? But I want to figure out how they got these numbers, okay? The X stands for the exterior, not the interior, the exterior depth. Right. So if the X stands for the exterior depth, the interior must be whatever the exterior is minus 5. Think about why that is true. Why minus 5? So let me write that down because I don't want to get you guys lost. X will stand for X equals exterior depth. That's what we're starting with. If X is the exterior depth, they told me here that the material is 5 feet thick. So if the exterior depth is X, then the material is 5 feet at the bottom, so the interior depth is going to be X minus 5. That's why they got X minus 5 right there. Interior depth. So you guys see how they got that for the interior depth or height. Then everything else they got from the information here. It says the interior width must be 3 times the interior height. So the width must be 3 times this. So what they did for the width is they took the X minus 5 and they multiplied it times 3. 3X minus 15. That's how they got that. Also it says about the length, the interior length must be twice the interior height. So if the interior height is X minus 5, twice that is 2X minus 10. So that's how they got those values for the interior height, interior length, interior width, using X as the exterior depth. Alright, now using those, now we can solve it. Here's what we're going to do. You're going to use the formula for the volume, which is length times width times height. For length, you're going to plug in 2X minus 10. For width, you're going to plug in 3X minus 15. And for height, you're going to plug in X minus 5. And then for the volume, we're going to plug in 6,000, which is what they told us. And then we're going to solve it. Alright, so let's get started on that. Alright, here we go. So I'm going to start by writing that the volume is length times width times height. Then I'm going to plug in all the values that I just said. For volume, we're going to plug in 6,000. That's what they told us in the information. For the length, we're going to plug in 2X minus 10. For the width, we're going to plug in 3X minus 15. And for the height or depth, we're going to plug in X minus 5. And we're going to try to solve that. This problem is going to take us a while. Here's the plan. We are going to multiply these out. Yes, we're going to get a little bit of a mess in here. Okay. Then we're going to move the 6,000 over to this side to make it equal to 0. And then we're going to try to factor that to try to solve it. Okay, so here we go. First, what we're going to do is multiply these out. So this one times this one, and then we'll do that one at the end. Okay, so 2X minus 10 times 3X minus 15. What I'm going to do is distribute. That times that, and then that one times that one, right? Like we did in the first section of this chapter, multiplying polynomials. So here we go. 6,000 on the left equals 2x times 3x is 6x squared. 2x times negative 15 is negative 30x. Negative 10 times 3x is negative 30x. And the last one is negative 10 times negative 15 is positive 150. Times the x minus 5 that I haven't touched yet. Let's keep going. 6,000 on the left equals. In the middle, this one right here, we're going to combine the negative 30x and the negative 30x to make negative 60x. So I have 6x squared minus 60x plus 150 times x minus 5 that I haven't touched yet. Now what we're going to do is finish. There's nothing else to do here. We're going to multiply this one times those two. Okay, so I'm going to go x times that one, times that one, times that one, and then the negative 5, the same thing, times that one, times that one, times that one. Okay, here we go. We're going to make it a little bit messier still. 6,000 on the left. X times 6x squared. X times 6x squared is 6x cubed. x times negative 60x is negative 60x squared. X times 150 is 150x. Do the same thing with the 5. Negative 5 times 6x squared is negative 30x squared. Negative 5 times negative 60 is positive 300x. 300x. And the last one is negative 5 times positive 150 is negative 750. Alright, combine as many like terms as we can. I know there's a few in there. 6,000 equals 6x cubed. There's no other cubes, so that was by itself. Done. The 60x squared and the negative 30x squared, they're both negative, so let's put them together. Negative 60 and negative 30 make negative 90x squared. The positive 150x and the positive 300x together make 450x. And then minus 750. Alright. So that was all just multiplying these things out. Okay. The goal, remember, is to solve for x. I want to know what x is. So what I'm going to do at this point is move the 6,000 over here by subtracting it so that it equals to 0. Once it equals to 0, I can see what I can try to do. But I want to put it in standard form, which means equals to 0. So we're going to subtract 6,000 to both sides. Otherwise, you can't solve this. You have to make it equal to 0. We're going to use the zero product property basically at this point. So that's going to cancel. And it's going to give you 0. And on the right side, you're going to have 6x cubed, which we had before, minus 90x squared, plus 450x. And then negative 750 and negative 6,000 make negative 6,750. Okay, so that's what we have left. Now at this point, I got to figure out what can we do with this to make it simpler so that we can factor. What we're going to try to do is factoring by grouping these two together and these two together. But first, I do notice, hopefully you try that too, you see, that I can make this easier by dividing everything by 6. If you divide everything by 6, your numbers are going to be much smaller, much easier to work with. And 6 does go into 90 and 450 and 6750. So we're going to divide everything by 6 to make it easier to work with. So divide by 6. The left side too, by the way. But since it's just 0, it's going to stay as 0. So on the left side, all you have is still 0. You're going to have x cubed because the 6 cancels. 90 divided by 6 is negative 15 x squared. 450 divided by 6, check with your calculator, but I think that's 75. Let me double check. And yeah, that's correct, 75. And then 6750 divided by 6 is 1125. Okay, much easier to work with. At this point, what we're going to try to do is factor by grouping. So I'm going to group these two together, and I'm going to group these two together to see if I can make it easier to work with. For the left one, what I can factor out is x squared. So factor out x squared. When you factor out x squared, what's left? It's going to be x minus 15, correct? For the one on the right, I believe you can divide them by 75. So let's see, divide 1125 by 75. See if that works. And it does, it gives you 15. So I'm going to divide out by 75. And what's left is going to be just x minus 15. And there it is, I see it. It's x minus 15. And the other one is going to be the leftovers, x squared plus 75. Equals 0. Let's not forget that it equals 0 on the left side. Alright, now to solve this equation, we're going to use the zero product property, which means we're going to set both of them equal to 0 to see what we get as a result. So x minus 15 equals 0, and x squared plus 75 equals 0. That's what we call the zero product property. When we solve an equation, we factor it out and we set each factor equal to 0. For the left one, it should be pretty obvious that x equals 15. And now if you notice the right side, to solve it, I would have to subtract 75 and I get x squared equals negative 75. And then I will have to take the square root of both sides to get rid of the square. And at that point I'm stuck. Because what happened, I have a negative inside the radical. I can't solve it. There is no real solution there. No real solution. So the only real solution we have is the one I found over here on this side, which is 15. Let's recall what we said x stands for. X stands for the exterior height or depth. So the exterior height is 15. Let's write that down. Is 15. It's asking us for the interior height, the interior length, and the interior width. So the exterior height is 15. You want to find the interiors. All you got to do is just plug it into each one to figure out what each one of those is. The interior height is going to be x minus 5, so 15 minus 5, and so it's 10. Interior height is 10. Interior width, that would be this one right here, right? 3x minus 15. So 3 times 15, 45. 45 minus 15 is 30. And interior length. Plug it in right here. 15 times 2 is 30. 30 minus 10 is 20. 20, is this feet? Yeah, feet. 10 feet, 30 feet, 20 feet. There's your final answer. That problem takes a long time. It takes a while to try to figure out. But let me give you guys a recap of what we did. We used the formula for volume, which is length times width times height. We used for the length 2x minus 10, for the width 3x minus 15, and for the height x minus 5. Those were given to you, but we could figure them out by saying that exterior height is x, therefore the interior height is x, take away 5 for the depth, for the thickness of the material. And then after that, we use the information here to say, oh, well, the length must be twice the interior height. So if this is the height, the length must be 2 times that, 2x minus 10. The width must be 3 times that, so 3x minus 15. Once we got that, everything else was just a mess of algebra, right? We multiplied everything together to get this right here. We moved the 6,000 over to the right side to make it equal to 0. We divided everything by 6 to make our numbers smaller. We grouped these two together and these two together to factor by grouping. We got x minus 15 and x squared plus 75. Of those two, the only one that gave me a real solution was this one, which is 15. The other one gave me a negative inside of the radical, which means that there's no real solution. There's what we call imaginary solutions in that one. So we don't care about it. The only one that works is that one. So I used x equals 15, plugged it into each one of my original pieces, and I got that the interior height is 10, width is 30, length is 20. All right, let's try this again. Number 6. To build a hefty wooden feeding trough for a zoo, its sides and bottom should be 2 feet thick, and its outer length should be twice its outer width and height. What should the outer dimensions of the trough be if it is to hold 288 cubic feet of water? Use x to represent the outer width. Okay, I'm going to organize myself here because there's a lot of information, and there was no givens, right? They didn't give me the expression that I should use for the height, the length, and the width. We have to figure those out. So what I'm going to do is I'm going to make a little mini table here for outer dimensions and inner dimensions, just so I don't get lost. There you go. And there are 3 dimensions. There is length, width, and height. Those are the ones that determine what the volume will be. They gave me one of them. It says there to use x to represent the outer width. So the outer width is going to be x. I'm going to start with that one. Using that one as my starting point, let's see if I can figure out everything else. It says that the thickness of the sides and the bottom of the trough should be 2 feet. By the way, it's going to look just like a pool. This is what the feeding trough is going to look like this one, with thick walls and a thick floor. The bottom has a thickness. The top is open because the animals have to feed. So Let's see what it says. Its outer length should be twice its outer width and height. Ooh, there's a clue there. The width and the height are the same, right? By the way they wrote it, it says that the length should be twice what the width and the height are. That means that the width and the height should be the same. So if the width is x, the height is x. The length should be twice as big, so it's 2x. Right? Let's read that again. The length, outer length, should be twice its outer width and height. There you go. What should be the outer dimensions of the trough if it is to hold 288 cubic feet of water? Okay, use x to represent the outer width. So they're telling me that the volume, let's write that down, is 288. How do we find the volume? By multiplying the inner length times the inner width times the inner height. Remember, to find the volume, you don't care about the outer, right? Because the thickness doesn't matter. You care about the inner. So using that information and using this, we can figure these out. If the outer length is 2x and the thickness of the walls is 2 feet, what is the inner length? Think about it. Think you guys can figure it out. If it's 2x all the way across, but the walls are 2 feet on each side, right, for the length, that means it's 2x minus 2 for this side minus 2 for this side. It's going to be 2x minus 4 for the inside, right? The inner length should be smaller than the outer length. Think about the width now. If the width is just x, but the thickness of the walls of the sides is 2 feet, it should be x minus 4 again, because it has thickness on both sides. For the height is different. Since it's open on the top, it only has thickness at the bottom. So you only have to subtract the thickness for the bottom, so it's going to be x minus 2. 2 represents the thickness of the bottom. 4 represents the thickness of the two sides. 4 represents the thickness of the two sides, because we're talking about width and length, so they have sides thickness on both sides. Alright, using that, now we can solve this. We're going to use the formula, plug in these values and the volume to solve. It's going to look like this. Here we go. Volume, 288. Start with that. Equals length, 2x minus 4. Width, x minus 4. Height, x minus 2. We're going to do the same thing we did in the last problem. We're going to multiply all of these out, which is going to get a little messy. We're going to move this over to the right side afterwards to make it 0, and then we're going to try to factor it by grouping. So here we go. Let's start by multiplying all of these out. In this case, I noticed in the last one that I multiplied these two first, and it ended up that I had a binomial on the right side, and I don't like it on the right side. So I'm going to multiply these two first. That way this one stays on the left side. Okay? So we're going to multiply these two. Why did I put a W there? Hopefully you guys did not make that mistake. Should be x, right? Everything is x. No W's, no heights. Okay, x times x, and then x times negative 2, and then negative 4 times x, and then negative 4 times negative 2. That's what we're doing first. So on the left side, just leave it as 288. Leave the 2x minus 4. We're not touching it right now. We got to do that one. X times x, x squared. X times negative 2, negative 2x. Negative 4 times x, negative 4x. Negative 4 times negative 2, positive 8. Combine like terms inside of that one, so 2x minus 4, x squared. Negative 2x and negative 4x is negative 6x plus 8. 288 on the left. We're going to again distribute like that, like that, like that, and then the negative 4 like that as well. So we're going to do it again. Bring down the 288 again. We're not messing with it yet. Let's start with the 2x. 2x times x squared, which is this one right here. 2x times x squared. 2x cubed. 2x times negative 6x. Negative 12x squared. I just did that one. 2x times 8, positive 16x. Alright, done with the 2x. Next the 4. Negative 4 times x squared, negative 4x squared. Negative 4 times negative 6x, positive 24x. And negative 4 times 8, negative 32. Combine like terms as much as you can. Here we go. 288 equals 2x cubed because there are no other cubes. Negative 12x squared and negative 4x squared together make negative 16x squared. Positive 16 and positive 24 makes positive 40x. And finally minus 32 there at the end. Alright, now we put it in standard form by subtracting the 288. We want it to go over to the right side so we can make it equal to 0. Right, those cancel out, make 0. So 2x cubed minus 16x squared plus 40x, negative 32 and negative 288. Put them together, it's going to give you negative, because they're both negative, and it's going to be 300, what is that, 20. Alright, now before I try to factor by grouping, notice again that everything can be divided by a certain number to make it smaller, make it easier. We're going to divide everything by 2. By 2, by 2, by 2, by 2. The left side too, right? Whatever you do to the left, you do to the right. Now on the left side nothing happens because it's just 0 divided by 2, so it's just 0. But on the right side you have x cubed minus 8x squared plus 20x minus 160. And finally we're ready to solve to factor by grouping. I'm going to group these two together, and I'm going to group these two together and see what I can get out. For the first pair, I can factor out x squared. And that leaves me with x minus 8. For the second pair, I can factor out 20. Right? They're both divisible by 20. And that leaves me with x minus 8. There it is. That's just what I wanted. I see x minus 8 on both of them. So x minus 8 is the first one, and x squared plus 20 is the other one. To finish it, set both of those equal to 0. That was the whole point of setting it equal to 0, of moving the 288 over to the right, so that I could do this last step. X minus 8 equals 0, and also x squared plus 20 equals 0. Solve the one on the left. That should be pretty easy. X equals 8. Done with that one. The one on the right, just like the last one we did, if you try to solve it, you're going to get x squared equals negative 20. Take the square root of both sides, and it doesn't work. So no real solution there. It does have solutions. They're imaginary. They're what we call imaginary, which is something we haven't discussed yet, but we're going to get to that. Okay. But for now, we're going to say that has no real solutions. The only real solution is 8. So x is 8. X stands for the outer width and the outer height, but they're asking us about what should be the outer dimensions. Oh yeah, the outer dimensions. Okay, so all we got to do is just say 8 for the width. I might just write it right here. 8 for the height, and 2 times 8, which is 16 for the length. There you go. Those are the outer dimensions. Alright, so I know that both of those were pretty tough, long problems, but I want to ask you guys to try one on your own. Keep looking back at the one that I just did. Look back at both number 5 and number 6, especially number 6 because it's very similar. So go to your side, please, and try number 3. Try to see if you can figure it out. The advice I can give you guys is to make a little table to organize yourself. And you're talking about length, width, and height. Length, width, and height. Using those 3 dimensions and using the inner and the outer dimensions, and using x to represent the outer width, right? That's what they're telling you to do. Try to figure out the other ones, and then also don't forget that the volume is equal to the length times the width times the height. You're going to take the volume, plug it in there, and whatever you have for the inner, remember the volume only cares about the inner width, inner length, inner height. Whatever you find for these, that's what goes there. And then continue from there. go ahead and try it. Pause it, take as much time as you need, and then come back and check my work. Okay, go ahead and pause the video right now. Okay, so here we go. This is all the work that I did on this one. Okay, I started by the table that I showed you guys to start with, using x for the width. Then once I use x for the width, I read the instruction that says that the outer length should be twice the outer width and outer height. So that means that the width and the height are the same. The outer length should be twice as much. So if width is x and height is x, the length should be 2x. Then I use the information about the side and the bottom that they should be 3 feet thick. So if they're 3 feet thick, the length is 2x minus 6 because you subtract 3 for each side. The width, same thing, it's x, but minus 6 because you subtract 3 from each side. The height is x, but only minus 3 because you only subtract the bottom side, right? The shed is not covered on top. Because it says that the shed's side and bottom should be 3 feet thick. It didn't say anything about the top. So using those, 2x minus 6, x minus 6, and x minus 3, I use the formula for the volume, length times width times height, set it equal to 972. Once I got that far, all I had to do was just multiply, so that's where all this mess comes from. I multiplied these two first, got x squared minus 9x plus 18. Then I multiplied times 2x minus 6, and got 2x cubed minus 24x squared plus 90x minus 108. Subtracted the 972 so that I could make it equal to 0, and I got negative 1080 over here. Everything else the same. Then I divided everything by 2, right? If you don't do that, you can still solve it, but it's just you're going to have bigger numbers that it's just going to be messier. So I noticed that they both are divisible by 2. I divided everything by 2. Got these right here. I grouped these two together. Got this right here. Then I factored both of them. To factor the first one, all I had to do was factor out x squared. Got x minus 12. To factor this one, I divided both of them by 45, and I got x minus 12. That's what I wanted. Now I see that they both have x minus 12. The other part, the leftovers are x squared plus 45. Set them both equal to 0. That's the whole reason why we set this equal to 0. X minus 12 equals 0 gives me x equals 12. X squared plus 45, I subtracted, try to take the square root, doesn't work because you can't have a negative inside the radical, so no real solution. Maybe you have noticed that every time you have x squared plus something and you try to solve it, it's not going to work. It's going to give you no real solutions. It should always be x squared minus something, and then it would work, right? But if it says x squared plus something, it's not going to work because if you try to take the square root, you're going to have a negative on the other side. That's the same thing that happened in my problem over here, right? Both of them. X squared plus 20, no real solution. X squared plus, what was the other one over here? 75, no real solution, right? It just does not work because of that plus. When you move it over, it's going to turn negative, and then you have to try to take the radical, and it doesn't work. Okay, so the only solution is x equals 12. So I went back to my table, and I actually figured out everything. That's what this table is. If x equals 12, this is 2 times 12, 24, 12, 12, 24 minus 6, which is 18, 12 minus 6, which is 6, and 12 minus 3, which is 9. They only wanted the outer, right? What are the dimensions? What should be the outer dimensions of the shed? So these are the ones they wanted. But I did that just to check. The volume is 972. To find the volume, we multiply length times width times height. So if I multiply 18 times 6 times 9, because remember, volume is only about the inner dimensions. If I multiply 18 times 6 times 9, I should get 272. And you do. If you do that multiplication, the volume there is 972. 18 times 6 times 9 is 972. So that proves that our answer is correct, which are these three right here. Right? There you go. That's the correct answer. All right, we're done. Your homework is correct. Page 278, 13 through 20, a lot of factoring, and then 23 and 26 where you have to check some mistakes by other students. Okay, so you are responsible for that, and I'll see you guys tomorrow.